There's one thing that I gotta hit that was not on the notes. We'll go over this quickly and then we'll do a bunch of practice in class. So I've got a big right triangle, triangle ABC, right triangle. Now if I draw in an altitude, so this altitude CD, notice it makes another right triangle right there, ADC. It makes another right triangle over here, CDB. So I have little right triangle, and the original big right triangle, ABC. And when I do that, all three of these triangles are similar to each other. So now if I take this triangle, ADC, and I separate it, and I flip it, so now it's lying in the same orientation as my original, there it is. So I just took out this little triangle, ADC, and I wrote it here on the same orientation as the original so I can compare my like sides. And I'm going to do the same thing to this little triangle CDB. So just this little triangle, I'm going to grab it and I'm going to turn it so that it's lying in the same position as my original big triangle. So there's my three triangles. There's my little triangle, another little triangle, and of course here's my original ABC. So now since they're similar, I can create proportions, which is what I'm going to write right here. So I'm going to take B over A. So bottom side of the original triangle over left-hand side of the original triangle equals bottom side of this smaller triangle, the Y, over the left-hand side of that triangle, Y over H, equals bottom side of the small triangle over left-hand side of the small triangle. So there's my all three pieces set equal to each other. Now if I can cover up this B over A, I now have a cross product that I can do. So I can do H times H equals X times Y. So H times H is just H squared. So this tells me that H squared equals X times Y. So if I go back to my original picture, it tells me that H squared, so this piece squared, equals X times Y. We'll use that in a second. So now I'm going to do it again. Go back to my original big triangle, take the hypotenuse, put it over the left-hand side. It gives me C over A right here. Then that must be equal to hypotenuse of this triangle over left-hand side, B over H, and that must be equal to hypotenuse of this triangle over left-hand side, which is A over X. So now cover up this middle piece, and you do have C over A equals A over X. If I cross product, I get A times A, which is A squared, equals C times X. If I come back to my picture, I have A squared, this piece squared, equals this X, this little piece, times C, the whole length. And I can do it one more time. I can take hypotenuse, big triangle, over base, big triangle, which gives me C over B, equals hypotenuse triangle over base triangle, B over Y, equals hypotenuse triangle, base triangle, A over H. And if I cover up this last piece, I can do a cross product. There it is. So I have C over B equals B over Y. I cross product these two. I get B squared equals C times Y. So B squared equals this whole piece, C times the Y. So that is the explanation. So here's what we actually have to remember. So here's my formulas. If in this triangle, I can take H squared, so this piece squared equals this piece X times this piece Y. A squared, this side squared, equals this little piece, this X, times the whole thing. And then this bottom side, the B squared, equals this piece, the Y, times the whole piece, C. Again, we'll do a bunch of practice in class. I just need you to be familiar with that. Okay, now to what I actually had y'all do on the notes. Angles of elevation and angles of depression. Then you got to remember that they are made from a horizontal line. So angle, this horizontal line here, and I have another horizontal line here. So this angle with this arrow is made between this line and a horizontal line. And this angle is made between this horizontal line and this line. So definition, the angle between a horizontal line and the line of sight to a point above the observer is the angle of elevation. So if I'm on the ground looking up, it's an angle of elevation. The angle between a horizontal line and the line of sight to a point below the observer is the angle of depression. I'm flying in an airplane, standing on a building, and I'm looking down. That's an angle of depression, but they have to be made with the horizontal. Very important. The angle of elevation and the angle of depression for the same setup are always congruent to each other. And think about why that is. I'm not answering it for you. Think about why that is. So now we're practicing. I've got angle 1 and I've got angle 2 in my picture. And it wants us to identify, is angle 1 an angle of depression, elevation, or neither? Same thing for angle 2. So angle 1 is made up between this vertical line and this line. Neither one of those is a horizontal line. So angle 1 is neither. Angle 2 is made up of this line, which is horizontal, and this line. And because I'm on the ground looking up, that's going to be an angle of elevation. Second one, if you haven't already looked at it, look at it. I can't cover these answers so easily. I guess I can try. Let's see. That'll work, I guess. So there's my new picture. So let's start with angle 3. Angle 3 is made up of a vertical line and this line. Again, neither one of those is horizontal. So angle 3 is neither. Angle 1, my airplane up here, it's made up of this horizontal line and this line. It is an angle of depression because it is made with a horizontal line and I'm in the airplane looking down. That's going to be an angle of depression. Angle 2 is made up of this horizontal line and this line. So I'm on the ground here looking up. That's going to be an angle of elevation. Of course, angle 1 and angle 2 are congruent to each other. This one. Okay, let's start with angle 2. We can start with angle 2. Angle 2 is an angle of depression. Why? Because it's made up of this horizontal line and this piece. I'm up here on this building or whatever, and I'm looking down. Angle 2 is an angle of depression. Angle 1 is made up of this horizontal line and this line. I'm on the ground, I'm looking up, it's an angle of elevation. And angle 3 is made up of this vertical line and this line. It is going to be neither. I got a few word problems. And again, like I always tell you guys, drawing the picture is half the battle. If you can get your picture drawn, you can usually get the problem. So I've got an observer standing atop a building that is 25 meters above the ground. So I drew my building. Here's my building right here, 25 meters above the ground. Here's my man standing at the top of the building. It then tells me I have an angle of depression of 27 degrees. So again, that angle of depression must be made with the horizontal. So I drew in my horizontal. This must be my angle of depression. So I draw in my triangle. So he's here. I can draw in my triangle. There it is. This must also be 27 degrees because these are always congruent to each other. And I'm trying to figure out how far is the car from the building. So I've got a right triangle. This is the angle that I know. This is the side that I know. This is the side that I want. So I know the opposite side. I want the adjacent side. That should be familiar to us as tangent. So I take the tan of 27 and I set it equal to the opposite side, which is 25, over the adjacent side, which is x. So I get tan 27 equals 25 over x. I don't want that x on the bottom, so I'll multiply both sides by x. When I do that, it gives me x 27 equals to 25. Then I have to divide both sides by tan 27 to get that x all by itself. And when I do that, I get x equals 25 divided by the tan of 27, which is x equals 49.1. So this distance, this car, is 49.1 meters from the building. So this is the second time that I've shot this video, because the first time I made a mistake when I was reading this one. And if you know what a spoonerism is, when I read the word, I'm going to be careful this time, fire truck, a while ago, I committed a bad spoonerism, and it would not have been very professional for me to leave that on the video. So I'm going to be very careful when I say that word this time. A ladder mounted on a fire truck is 6 feet above the ground. The maximum length of the ladder is 120 feet, and the measure of the largest angle that the ladder can safely make is 75 degrees, how high will the ladder reach if it is on top of a 6-foot tall truck? Alright, so here's my drawing. So this rectangle right here, that's my fire truck. This is my fire truck. So it's 6 feet up. That's what it tells me. Here, this is my ladder. And it tells me the maximum length is 120. So that ladder, and this is the building. This angle, it tells me, is 75 degrees. So there's my right triangle. Right triangle. This is 75 degrees. Calling this X. Calling this 120. So again, this is the angle that I know. This is the side that I want. This is the side that I know. I know the hypotenuse. I want the opposite. So which trig function uses the opposite and the hypotenuse? It is sine. So I can write the sine of 75 degrees equals the opposite side over the hypotenuse equals x over 120. Multiply both sides by 120, you get 120 equals 120 sine 75 equals x. Put that into your calculator, you'll get that x is equal to 115.9. But notice that is x, that is this distance. And the question says how high will the ladder reach? So how high will the ladder reach? So it wants this whole thing. How high against that wall will the ladder reach? But I already know this is 6. So I can take this 115.9, add 6, the height of the fire truck, and I'll get 121.9. Lots of examples in class. I just need you to be familiar with this.